This video is going to look at translations and transformations of trigonometric graphs. Now you already know the basic sine, cos and tan graph. We're just going to look at the translations and transformations of them. So let's do an investigation on our calculator. We need to make sure our calculator is in radians, so the top right hand corner of your screen. And we're going to change our window. So window settings, we're going to go from, let's go from negative pi up to 4 pi. So 2 revolutions in the right hand or the positive x axis. And our scale, we will make pi over 2. And then for our y-axis, we'll go from negative 5 to positive 5, and we'll go up in a scale of 1. Okay, so let's go for our basic sine curve. So here you can see our basic sine curve, its amplitude is 1. So it's going between negative 1 and 1. And its period is 2 pi. So we have 4 pi in the positive x direction and we have 2 cycles. So every 2 pi, it's rotating again. Okay, remembering that our graduations on our x-axis are pi on 2. I quickly will go through where these values are coming from, remembering that sine is our y-coordinate. So in our unit circle, our y-coordinate is, when our angle is 0, our y-coordinate is 0. So that's why it's starting at 0, 0. At pi on 2, my y-coordinate is 1. At pi, my y-coordinate is 0. At 3 pi on 2, my y-coordinate is negative 1. And then at 2 pi, my y-coordinate is 0. I'm back at the beginning. And then I rotate around that unit circle again. So let's do some translations. If I put a 3 in front of my sine x, what happens? You can see the amplitude is now 3. 1, 2, 3. So the number in front has increased all our y values by a factor of 3. Testing that, if I point 0.5 sine of x, I now have an amplitude of 0.5. So the number in front tells us our amplitude. I've gone back to my basic sine curve. Now let's investigate something else. If I go sine of x and I go plus 3, what happens? My sine curve, if you look at this starting point of 0, 0, it's gone 1, 2, 3 units up. If you look at this maximum point, it's gone 1, 2, 3 units up. My whole sine curve has translated upwards 3 units. So this plus 3 is a vertical translation. It's positive. It's moving the curve up. So if I have sine of x and I take away 2, what's going to happen? Our curve has translated down 2 units. So looking at the 0, 0 point, it's gone down 1, 2. Our maximum's gone down 1, 2. Every point on the original curve has translated 2 units down. So minus 2 is translating it down 2 units. That's a vertical translation. So I've gone back to my basic curve. Let's look at something else. If I go sine of x plus pi, what's going to happen? this curve, my original blue curve, has translated. The plus pi moves it to the left pi. So pick a point. If you pick this 0, 0 point on my blue curve, it's moved to the left. Pi on 2, pi. Remembering that each graduation on our x-axis is pi on 2. So it's moved pi on 2 to the left. Every key point, so if we look at this maximum turning point here, it's moved 1, 2 graduations, which is 2 lots of pi on 2, so it's moved pi to the left. So if I go sine of x minus, and let's go pi over 2. So if we look at the black curve compared to my original blue curve, it's moved 1 graduation to the right. So this 0, 0 point on my blue curve has moved to the right 1. I'm going to get rid of the red curve just so you can see that a bit better. Okay, so you can see that the blue curve has moved to the right pi on 2. So if I have minus pi on 2, it moves to the right. Let's go sine of x plus pi on 2. So the red curves move to the left. So plus pi on 2, it translates horizontally, left pi on 2 radians. Negative pi on 2, it moves to the right, pi on 2 radians. That horizontal translation is what we call a phase shift. So it's moving left or right. I've gone back to my basic curve. Now let's look at reflections. So if I go negative sine of x, what happens? The red curve is a reflection of the blue curve in the x-axis. So that minus out the front reflects it in our x-axis. No different to any other curves we've been looking at. The negative out the front reflects it on the x-axis. Let's try sine of negative x. Now that black curve is over the top of our red curve. So negative sine of x is exactly the same as sine of negative x. Okay, negative x is a reflection on the y-axis, but you can see that this blue curve, if reflected on the x-axis, is exactly the same as if it's reflected on the y-axis. Another thing to note is that the number in front is always our amplitude, and the negative doesn't impact that. The negative is the reflection, the number is our amplitude. Okay, so that negative is a reflection in the x-axis, and my amplitude is 2. My amplitude is not negative 2, it's 2. So I'll put into sine of x. The amplitude is the same, but it's a reflection of the negative 2 sine of x in the x-axis. So remember that your amplitude is the absolute value of what's in front of the sine of x, or whatever trigonometric ratio it is, and the negative is the reflection. Now let's have a quick look at our cos curve in relation to sine. So whereas our sine curve starts at 0, 0, our cos curve starts at 0, 1. And again, It's because of our unit circle. Thinking of our unit circle, cos is our x-coordinate. So our x-coordinate, when our angle is 0, is 1. It then goes to 0 when our angle is pi on 2. -1 when our angle is pi. 0 when our angle is 3 pi on 2. And then back to 1 when I'm back at 2 pi. Okay? That's the difference between sine and cos. All our translations and transformations are the same for our cos curve. Okay? So if I put a 2 in front of cos, that changes the amplitude. It doesn't change our period. Our period for a cos curve is 2 pi, just like our sine. If I go cos of x minus pi, it's going to move our curve to the right pi. So you can see, compared to the red graph, it's moved to the right pi. So I've gone back to my basic cos curve. Let's look at our reflections. If I put a negative in front, reflection in the x-axis. There you go. What about cos of negative x? It's now the same as my blue curve. Oops. So cos of x and cos of negative x are the same. Why? Think about our cos ratio. In the first quadrant, it's positive. Second quadrant, negative. Third quadrant, negative. Fourth quadrant, positive. So anti-clockwise, it goes positive, negative, negative, positive. Now let's go clockwise. Positive, negative, negative, positive. That's why these two ratios are the same. So in summary, the A that's out the front is our amplitude. It's the absolute value of what's out the front. Our B, which is in front of the X, is going to be part of our period. So 2 pi over B is our period. Now you can think of A, our amplitude, as being a dilation from the x-axis, and that our period is a dilation from the y-axis. Our plus or minus C here is our phase shift. If it's positive, it's going to move to the left. Negative, it moves to the right. Remembering your phase shift is the same as a horizontal translation. Then we have the plus or minus D at the end. That is our vertical shift. Positive moves up, negative moves down. Now, tips for sketching. Always start with a basic sketch, just a quick little sketch of your basic graph. The shape of sine, the shape of cos. Factorize if necessary. So you can see here with this summary that B is factorized out. You need to do that because you need your phase shift separated from that. Look at your amplitude, then look at your vertical shift. Those two things together, your amplitude and your vertical shift, will give you your minimum, your maximum, and your middle points on the y-axis. So if your amplitude was 2, your original graph would be -2 to 2. If that shifts up 1, so it has a vertical shift of 1, then our minimum becomes -2 plus 1, which is -1, and our maximum becomes 2 plus 1, which is 3. Okay, so it moves it up. Our period, divide your period by 4. That will give you your x-axis. And then worry about your phase shift. Your phase shift can come after everything else.